started back in 2015, and it started back in the US with the goal to bring more diversity into data careers. And it was simply because the number of women in tech is still significantly lower compared to what it was about 7 years ago. And I did a chapter, and a chapter started back in 2020. At that time, it was founded by somebody else, and I started leading the chapter back in 2023. Now we have 800 members in the community. The main goal of WID is to make sure that all the women who are part of the community can get mentorship, they can get support to build a career. We have a lot of people from different walks of life who are, for example, transitioning their careers, or for example, who are trying to upskill themselves or build confidence. So Women Data provides a platform, and it's non-profit. So there is like basically zero benefit of like anything that Women Data gets out of it. We also do a lot of charity funding through which we ensure that a lot of people who don't have resources, they can get education, and we have been able to support a lot of women. I would say this year we support almost 100 women around the globe. Funding we did through the WID platform. So that's the story of how WID started and how it was basically expanding in London. And to move forward here. So this is the vision, mission, and goals essentially. If you read on the screen, like we want to just create a world where we have equitable gender balance, and again to increase more diversity. If you have any questions or if you want to explore more about WID, you can use this QR code. It will simply direct you to the website, and you can join any chapter. We have 53 chapters around the world and 70,000 community members. It's very active in the US, in Europe we have a couple of chapters, including the Kalaivanan, and there are a couple of chapters in Asia and Australia. And if you have any specific questions or you would like to speak at one of our events in the future, you can contact me or connect with me. And these are some of the socials. If you want to basically check out the socials on Instagram, let me know there. And with that, my chat comes to an end. I will hand it over back to Sneha and Will.
Excellent. Great community. I joined myself recently and hope to learn more about what you're doing. Great. So that brings us to the course talk. Also, yeah, if you want to talk or if you want to speak at the event, sorry, please reach out. There's a QR code which you can scan here, of course, which is fine, Will, or you can email as well. But yeah, I've been to a few of these myself, and I think some of you guys have as well. Some really great talks. So please reach out. Can you help? Okay, if you're interested in speaking, but you have other opportunities, other areas of support that you can provide, please reach out as well, because we're looking for folks to help organize these events. And that brings us to the agenda for this day. So we've got 3 great talks. The first is Maria, who's here from Amazon. She's a senior product designer, and she's got a really cool talk that she put together very recently. Actually, where is she? Oh, she's over there. It's about storytelling and AI, and it looks really cool. The second is Celeste over there from Snowflake. She's a developer advocate, and she's going to talk about Apache Spark pipelines, which let's see how that works out. And last is yours truly. So I'm going to be doing a lightning talk, or a slightly more random chat, about personalization, which is the field that I now find myself in. I'm a senior PM at Tesco. And with that, community announcements and community announcements now. All right, I'll pass it over to Maria.
Alright, I didn't really know if I need the amplifier of my voice, because I feel like I'm loud enough, but let's see. So today we'll be talking about AI design patterns and AI storytelling. So what has changed for design in the past years? It really shifted from designing from deterministic systems and systems where we can predefine the output that the user will see, to probabilistic systems. So we do not really know what will happen. Previously, we knew that if the user will click the button, they will get the form. Now we query the chat, and the output that we'll get is not exactly clear. And another part of the big change that has happened recently is introduction of conversational AI. So it's predicted that conversational AI market will grow almost 4 times in the next 5 years, which is another that the relationship that we are building is much more nuanced, and we are much more responsible for the emotional relationship with the product. Previously, a specific product would only just drop the form or drop on the table and we would be 100% sure about this output. But now, with probabilistic systems and with unclear chat responses, we are 100% responsible for the impact that this experience will make on the user. So the question that I'm asking myself quite often when I'm designing AI products is, what kind of relationship I'm building with the users? What kind of experience they have when they are interacting with my chat or with any AI-enabled feature or product? And these days we like to think about these products as agents, and we like giving them human response. So for some reason, AI agent, which has nothing to do with human, nothing to do with having a face or character, suddenly became a human, AI human. For some reason, we decided that this is the best way how we can build a relationship with the system, we can build trust for the system, and build a better engagement and a better output for the user. So, which brings us to the first question. How do we build trust with such systems which are undetermined? Well, pretty much like we are building trust with humans. You meet a person, you look at them. Do they look like they're taking care of themselves, clean clothes, do they show up on time? We are creating some expectations if they are starting to speak or act. And then, as they are slowly progressing in whatever they are doing, we make a conclusion. Can we trust them or not? It's exactly the same as AI system. We open a website or a product, we make a decision. Can I trust the system or not? Did they take care of the user experience on the primary level? So is it actually branded? At least, is it well designed on the level of spacing? Is it well thought of? Well thought out? And then we are judging the experience in itself. I've taken a look at 3 different popular chatbots and asked them the same query. The query was psychology shifts and images. And I've taken a look at the examples of the answers. ChatGPT gave me a very interesting answer, so it was a pretty long answer, but as you can see, it was structured in a very bold manner. So ChatGPT gave me bullet points, a lot of emotional language, using empathy, a couple of links, and that's pretty much it. So it felt like I'm chatting with my friend, not really a very advanced system. When I was chatting with Claude, maybe because I have a paid subscription, or maybe that's how it's built, but the answer you can see it's distinctly different. So he started diving into the key sheets this year, giving me much longer answers, diving into the details. Perplexity is quite similar to the Claude Code. Again, we can see lots of references, the output is well structured, it is detailed. We can query the system further, and Perplexity as usual gives us 5 follow-up questions. So the same question, and like I mentioned earlier, we cannot exactly know what will be the output. As designers, we have to define how the output will look like and how to make it feel. All of these 3 systems are achieving this as well, but the relationship that we are building with the user is totally different. One of the things like when I'm chatting with Perplexity, I'm chatting with my authoritative tutor. When I'm chatting with ChatGPT, because like I'm chatting with somebody who just maybe my neighbor or pal Jim. Aside from that, I wanted to talk about different AI products and new experiences, new patterns that are emerging in design aside from this conversational experiences. And let's take a look at Illicit. Illicit is very interesting product because it is AI first solution for research. And we'll take a look at a couple of these products again to take a look to understand how they are approaching the output generation. In this case, I have queried it for AI in maternal health, and look what's happening. So first, it gives us very simple the process, so searches for the papers, finding the concepts for each source, removing duplicate concepts, and generating the final answer. Well, this is quite simple. But in a larger scheme, I can also see a different, much deeper dive into what is happening. Probably it's hard to see here, but trust me, it says screened in 9 papers utilizing criteria. And then it lists the specific criteria. So it not only references the general structure of how deciding which sources are good for the output, but also gives me an insight into how it filters the sources down. So we are building the trust that I mentioned earlier with the system on the very first step. But what's happening after that? The system created the full paper for me. I gave it very minimal insight into what I want to achieve or what I want to get, and it already created the full paper. It feels like they have somebody to control and decided what would be the best for me, which is a fabulous approach in some cases. I can just check if the references that were used are credible. I can read the article, make some adjustments, but by and large, the system has taken care of everything. Just like with complexity and with code, they have dived into the matter and generated the output. It is a very different approach from generation sentence by sentence. This product allows us to co-create this paper or article together with AI. And on each step, I can accept, I can adjust, I can change the sources used for generation of each sentence, and I can try again. Which means that user and the system are co-creators. It's a very different experience compared to the first one, where the system decided this is the output that you want, probably, please use it. In this case, we are just jamming together and coming up with the best output. I can even edit the sources, change the narrative, so I'm the owner of the final output. But what if, for example, I don't really like what is generated by the system? We have use another solution that helps us create articles and research papers. And here, instead of forcing the user to go into the chatbot and shifting their attention to a different model, we allow them to interact in line with text, in this case, could be also media, and to shift the responsibility from the user on deciding what they want to edit, we also suggest them smart options. For example, I want to add an example or create a list, or maybe transition between ideas. So I do not need to actually think of what would be the best for me to do here. Because one of the biggest problems with these systems is that I need to decide what I want to change. And sometimes it's hard to actually pinpoint what is wrong. You know, we feel something is wrong, but how do we know how to express this intent? Sometimes we don't. We can generate entire paragraphs, and again, we are working step by step, either chapter by chapter, or page by page. Still, the process feels a little bit more collaborative compared to generation through paper written prose. Here I can also select the text that I want to edit, and I can also almost chat with in this case, I don't remember the number and the name of the product, but I can chat with it and in the interactive manner almost keep editing till I'm happy. What about other types of systems? For example, if we need to work with media, would it work the same way? This is part of Figma experience, Figma product, and I can select the component, and again, ask for the edits, contextual development in this case. essence of this experience is how we can communicate the output in a better way compared to previous text-based outputs. Because when we are talking in the chatbot, most probably, we have seen structured output, structured in the paragraphs, bullet points, sometimes tables, but that's not much, right? So still there is a lot of text, a lot of content that we need to process. How can we help the user to arrive at the insight much faster? Consensus is another research solution. I can query it, for example, carbon capture technology, readiness, and I will get the response. In this case, I can see that they have generated the timeline for me, evolution of carbon capture technology readiness. In this timeline, I can click on any point and see the details of the references, what has influenced this shape or this location. Again, it's much easier for me to scan this output. Same with deciding on different opinions on this topic. It's much easier for me if it's color-coded and I can get a quick snapshot instead of processing pages by myself. Same with here the evidence and color-coding evidence strengths. And on the one hand, when I'm looking at this interface, it feels like it's almost childish. It's simplified to a manner that we have short bullet points, short phrases, colors, media maybe. Is this enough to build trust? And the question here is that if you remove the referencing and the papers, it probably would be way too simplistic indeed. In case of consensus, which is built on referencing the specific research papers and specific paragraphs within these research papers that support the point, that's not the case. That's why in each of these rows we have these multiple references. I can again click and dive into it. One more fabulous example, I created this system for the best places to build a restaurant. Immediately, in a matter of seconds, I can see where that is. But what about more advanced interfaces? Can we create an interface that would be interactive with the user within, for example, trip planning? Because we might have a simple chatbot that will help us build the trip, but would that be the best, the most engaging, and the easiest way for the user to plan the trip? Likely not. What if we could build more emotional relationship with the user by showing them the map, the media, the photos of these experiences, also enabling them to interact with us? For example, I can book a trip here. I can look within this map. I can see where exactly I will be leaving. I can also obviously query the chatbot, make adjustments to the map, and make adjustments to the entire trip, make it cheaper, define what I want to see, but in general, we have created a new interface for the user to interact, to, again, make the experience much more easy and build a better story. This seems like a little bit overloaded experience, and is a tool that is used for sourcing the candidates. I have created it to find the designers, and what it produced is a list of designers. Here you can hide and see them, quickly see the past experience, and get the reference of them in the portfolio, key skills, and all of this is again supporting us from the chat-based experience where we would need to either work with a table like this, which is a lot of data we have to process, or work with very long list. Sometimes we need to create extra media to support the point. In this case, I queried the analytics product to analyze my traffic last once. Aside from just producing the long text output analysis and supporting it with some tables, it created extra charts just to support the point and make it more interactive for me. And my favorite part is how media generation is shaping using AI. Again, a simple example from the us have tried generating an image using Gemini or ChatGPT, just put it produces you the image. Sometimes it produces a couple of images, so you need to select which one serves the best purpose and continue according to the typing. But what if we help the user to express their intent in a more smart way? And we are shifting right now to canvas-based creative workflows where I can either create a prompt myself or help a user create this prompt. For example, if the prompt is too short, I will enrich it to make sure that we are creating the output that will be as close to the desirable one as possible. But what's more, quite often we need to tweak the output a little bit, or quite a lot. And sometimes we need something more than just a prompt. For example, in this case, you can see the settings below the generated output. The settings include the resolution, seed, style, and more. So instead of forcing the user to think of all of the possible settings they need for this image, we are surfacing them immediately. And changing these settings is a matter of 1 to clicks instead of trying to recall what I needed to include in this prompt. Same idea, we are importing one image, one reference, and using the smart presets, we can generate multiple results here. Or, again, we can use a text-based experience. We can query the system to create videos and work with these videos, and again, produce more assets. So it is a combination of inline editing and editing using the chat. You can see the inline editing in this case. The product generated this image, and we can still change the resolution instead. Copy this product and turn it into text, image, or video. And my favorite example here is how we can make the how can we surface the intent for the user using very simple abstraction and turn it into high quality output. Sometimes in video, it's very hard to express what exactly we want to get. We might have this image in our head, but expressing it using words is tough. It's tough even for designers, and definitely hard for others who do not have vocabulary for this. But everybody can draw, and in this case, I draw a very simple building. Create the system what it should be in the hand. It should be front-facing architecture and brutalist building concrete, and that's what I received. Even more live, I can draw top of my image and it will redraw the output immediately. Even more, I can create extra imagery, combine this my drawings and AI-generated images, and produce the output in a matter of seconds, which would be completely impossible if I were to generate this just using my vocabulary and my prompting techniques. So, thank you very much for your attention, and
yeah, anyone have any questions for Maria? Or, sorry, I missed the name of the platform that you used.
which platform?
I missed the name that you, of the platform that you were showing.
There are dozens of platforms.
The one with the first one.
Listed.
Okay, so you just use a different one for each use case, yeah?
Yes.
Okay, thank you.
Yes.
To conserve maybe credits, let's say for the core cloud models or for the OpenAI models as well. In the future, do you envision sort of like a workflow or information architecture to be more instruction-led instead of like question-led? Because I'm assuming if the more words you put into the model, obviously the model would only sort of dries out. And with models maturing over time, you not only have to account for model drift, but also model quality and degradation. So I mean, in future, with AI being embedded into like systems and applications instead of being like standard chatbot, do you think it would be the right architecture would be more like sort of instruction and sort of us asking questions?
Yeah, definitely. I think there is a place for the controls, which help us define the output much faster than requiring it using free prompts, free text prompts. So surely, if we want to produce the best output for the user, that would definitely be a shift towards controlling the output with some smart controls, and maybe starting with high quality first either output generated by the system based on the expected intent of the user, or helping them frame the intent in the best possible way. For example, it's clear, just a simple abstract image is significantly better than prompt, say, 20 pages long prompt. So definitely much better means to express intent and try to improve text.
Sorry, for a follow-up question. Then would the priority be model freshness instead of context window? Because you don't need that many words to describe like a simple output. Then I mean, you can use like smaller SLMs or even like LLMs to do the same task.
Yeah, that makes sense.
And what do you think of harness engineering taking over this space in terms of having like multiple agents doing different aspects of it, and then like spawning its own reviewers, and then accepting it and things like that, and then evolving into a much better piece of art or story that you talk about? So
yeah, I mean, sure. In terms of agent usage, it is something that should not be surfaced to the user, or at least should be hidden as much as possible, because it's not the user's problem to be diving into the technical detail of it. So if we can save the user from knowing that they have used agent that analyzes the image, an engine that analyzes files, sources, if we can save them from that, that would be the best information. Surely if that helps us optimize the process and probably helps us with the latency, that is an optimal solution. But from the user experience standpoint, the least amount of burden, technical burden, is the best in my opinion.
So do you see, I mean, this seems to be evolving towards some kind of creator economy, indeed, right? Like if that is coming in, then the users would want to have more empowerment in their hands to modify and maybe not get into technical details. Like, for example, I can write Adobe Photoshop as a software, but I can't really edit photos because there are so many amazing plugins and tools that I'm not aware of, which a photographer would be aware of, right? So like a creator economy coming out. So do you see that as well evolving from this?
Yeah, I think regardless of the user, if we are speaking about the mass market, we still want to produce this experience that is as simple as possible. Unless we are defining some unique case, for example, in this case, actually, it was a creative workflow, but it is an advanced workflow, okay? We need to keep in mind that I have included this as an example, not something that would be used by 90% of people. So yes, it does include the control with smart presets, but it's not exactly the experience that we want to subject for all the users that we have. So probably closer to promoting using simple abstractions.
Thank you. Great. I wish you were around the other day when I was using Gamma and I prompted it to make sure that all of the bodies in my photos had heads. I was running out of credits. Pizza, everyone. Let's grab pizza and come back here in about 10 minutes.
I was going to do some like quote-unquote live coding. I was going to show you the terminals. This might get a little sketchy, everybody. Just be really supportive, okay? That's the key thing. Cool. So my name is Celeste Horgan. I am a senior developer advocate for open source at Snowflake. What senior developer advocate means is that I come and I give a lot of talks at conferences and stuff, and I create technical content. What that means for me in specific is I actually spend about half of my time doing upstream contributions to projects like Apache Spark. But I also spend a decent chunk of my time facing internally and running Snowflake's open source programs office and making sure that we don't get sued when we decide to open source things. So that's not what this talk is about, but I do love talking about open source programs offices, so if you want to have that chat, come find me after. This talk is about building Apache Spark pipelines, specifically to detect raccoons. Okay, this is a slide that Snowflake makes me display. As you can see, it's a very interesting slide, and I'm sure you're all going to read it in a huge amount of detail. Yay, we saw the slide! Okay, so, who here knows what Apache Spark is? Or has used it? Okay, so about half. This is really intended as like an introductory talk for Spark when I give it, so like for you guys, like just please, again, be nice to me. The next thing we're going to talk about is what Spark is really, really good at. We're going to build a bit of a data pipeline, and then we're going to have a question mark, profit sort of moment towards the end. Yeah, let's rock and roll. So, Apache Spark is like a really hard project to understand. Even if you've encountered it in production, I think it's really easy to misunderstand what the project is, and certainly when I started getting involved, upstream on Snowflake's behalf, it took me a while to grok what this thing was. And the best description I have, and the entire reason that this entire talk is Raccoon themed for no good reason, is that it's like kind of a bunch of raccoons in like a trench coat. It's really a bunch of like functionality that is kind of distinct both in its implementation and its use cases that are unified by kind of this Spark runtime layer. And the entire purpose that Spark exists is to allow you to do data pipeline things. So you're typically never deploying Spark on its own. You're feeding data from something, you're doing something, and you're feeding it away. So, what are the raccoons in the trench coat? We've got kind of large-scale extract, transform, and load pipelines. This is a lot of what you see Spark in production for these days. Spark is typically deployed as a cluster, so it's not really like a single node thing, and it is typically used for really, really large-scale data transformation. The reason it's like such a sticky piece of software is because that cluster architecture makes it very, very stable to run these kinds of workloads, and so it's the kind of thing where it's like once it's deployed, it's like really hard to get rid of. So, you know, we'll talk about this later in the talk, but like, it's very, very common that you deploy Spark, but I don't know that you would want to deploy Spark necessarily in 2026. It's more just like you're going to encounter it, so it's good to know a little about it. And it's usually for large-scale ETL stuff. Another sort of branch of the weird Spark world is this entire functionality called MLlib. It does inference and other sort of classical machine learning algorithm processing. It doesn't do like inference or generative AI, so it's, I hate to say it, it's probably a little bit out of date now, but if you are doing more classical machine learning like functionality, it's definitely an option, and especially if you've already got a Spark cluster running, you may as well evaluate it. Another thing it does is near real-time stream processing, which sounds really weird, and you're probably thinking, but why don't I use Apache Kafka? And you totally could. It's the kind of thing where it's like if you've got a Spark cluster running, you could probably consider it. It also does sort of SQL-based data analysis, so you can kind of perform joins and like perform like lookups and stuff like that. It also does graph processing and a whole bunch of other things. So it really is like, I always like to think of it as kind of the transform layer superhero. It is very much a Swiss Army knife of a project. I would say the core of its functionality is really just churning through huge data sets or doing like transforms and loads on like really, really large amounts of data. but it can do enough things that it has a sort of like stickiness to it once it's in deployment. And in comparison to a lot of other data pipeline tools, the thing that comes to mind, especially with Splink actually, it is very, very robust and very, very stable, which makes it really suited for big data in production. That said, it does kind of suck, and I think it is really important to talk about the ways in which projects suck and why you might not want to choose them. So the thing with Spark is, I think it was donated to the ASF in like 2012 or something like this, so it's starting to show its age. It's like a big, heavy JVM-based thing, so it's not like a light deploy. It's, you know, MLlib at this point is maybe like not the best library for doing machine learning related stuff. There's like way better options, especially in 2026. And I think this particular crowd knows a thing or two about those options. It was really built to kind of pair with Hadoop and MapReduce. Like the ASF, when they accept projects, really like to accept projects that play nicely with the rest of the ecosystem. If you read through the documentation in detail, and it's an open source project, so things don't always get updated that quickly, it's still talking about Hadoop and MapReduce, which again, I would say that neither of those are maybe the correct infrastructure choice in 2026 for doing data and analytics, so we'll certainly encounter them. So it's a bit hard to sort of like translate those concepts into things you might want to do in 2026, and I think that just is part and parcel of this ecosystem. But the chances that you're going to encounter Spark at some point in your career as a developer are super high, regardless. Okay, I would say the key thing to understand about Spark, though, is it's an intermediary step. It is a data processing step. It is not like a place where data lands. It's not a place where you would want to store data long term. It's a pipe to move through. So speaking of pipes, let's build a pipeline, as indicated by the raccoons in the pipe. Thank you very much. So what are we doing? I am very poor at inspiration at the best of times, so I decided that our pipeline should detect images of raccoons within a larger data set of images of animals. So we're going to set this to an Apache Kafka topic, again, just to really like drive home the point that like you want the data to go elsewhere. You don't necessarily have to send it to Kafka, it's just like the thing that came to mind when I was building this. So really what we need to kind of get ourselves started is we need a large image data set. We need to do visual inference against it, so we need a model that we can then sort of train and work with. And then we need to analyze the data set for raccoons. I need to untangle my foot. Okay, so you may be sitting here thinking, Celeste, why raccoons? No real reason other than I made the very first slide in this presentation first, and that image of like the raccoons in the trench coat just sort of stuck with me as I was like building out this presentation. They're evil. With their cute cat-like ears. How many of you have met a raccoon in person? Sorry, this is Europe. I forget that it's Europe sometimes. So raccoons are very, very common in North America. I'm from British Columbia, Canada, which is where Vancouver is. It's just north of Seattle. They're about as common there as foxes are here. So you see them all the time, and they cause all sorts of raccoon-shaped problems. In Vancouver, they're affectionately known as trash pandas because they like to eat trash. So that's my relationship with them. They do look adorable like little bandits, but like they will rifle through your trash. They're wearing burglar masks, evil, and they dig through your trash, also evil. So we should probably filter out the raccoons because we have to assume that here in Europe, they are invasive. Okay, so this is where I'm going to attempt to do a little bit of coding directly in front of you, and again, you're all going to be very supportive. I usually say this in my talks, but I didn't get around to it this time. I actually began life as a technical writer, so I was doing software documentation for many, many years, which is why you're going to be extra supportive of my attempt to do coding, okay? Okay. What I'm actually going to do, and sorry, I'm just setting this up on my laptop, is I'm going to walk you through the pipeline, and then we're going to actually run the pipeline. I will say that the model is pre-trained because the data set that we're working with is like 60,000 images across 3 Parquet files, and I'm like not going to do that to you. Because that would take like 3 hours, and also Hugging Face doesn't want to talk to me right now for various token-related reasons. So this is how we're doing it, everybody. Okay. Do I want to try and mirror the display? No, that doesn't seem to be working. Okay. We're here. See, the problem is now I have to like talk at the screen, and also remember how to get the cursor over. Okay. So, I whacked every. Oh yes. So I don't. Okay, we're gonna do it this way, everybody. So, very quickly, there's some boring stuff up front. We're gonna use PySpark as our Spark implementation of choice. This is because I know Python best. The other thing we're using is obviously the sort of Kafka library to build just like a local Kafka cluster. Kafka, for those of you who don't know, is a stream processing tool. So if you want to like plop data into a Kafka topic as you go, that is a thing that you can do. So we're going to use PyTorch to train the model. Like I said, the model is already pre-trained because I'm not interested in doing that to you live. That would take like an hour or 2. The other thing that we're going to use is the Hugging Face transformer for visual inference. And before I go on, let's go back here for a second. This is what PySpark is. We just discussed it. The one thing that I would note about the Spark packages, if you do have to implement Spark, the different language packages implement Spark in different ways. And there are some pieces of functionality that aren't available, say, in the Scala package, notably data frames, that are available in PySpark. So it is like something to keep in mind, is that your experience of Spark may not be the same from package to package. Speaking of which, we're not going to talk about a data frame just yet. We will talk about an Apache Parquet file. So who here knows what an Apache Parquet file is? Okay, we got one. So Apache Parquet is a way of storing large data sets, particularly data sets that have been like annotated or otherwise structured, and sort of compressing them for typically storage on like an S3 bucket. So now let's see if the demo gods love me. Ooh. Okay. Those are my notes. We're going to pretend you didn't see them. What do I want to see? What do I want to see? I want to see my folder structure. I opened the folder. Why are you doing this to me? Open. Rude. So I'm just going to kind of show you the data set. So, what am I looking for? I am not going to open these. So our data set is a set of about 60,000 images of various animals. This was found on Hugging Face. It's stored across 3 Parquet files, and I want to say it's about 12 gigabytes of data. Ironically, the original data set does not have any raccoons in it, so it is a European data set. So something that we have to do in our pipeline is populate the data set with raccoons so that we can then detect the raccoons, which is hilarious, but we're going with it. So we also specifically have a data set of raccoons. Kicking around here, this is just a separate data set of raccoon images, and also where all the images, all these slides have come from. So, going back to make.py, if I can find it. Normally you would want to be like more organized about this, but this is just for the purposes of talking about Spark. The first thing we're going to do is we need to sort of pre-train our model. We're going to use Hugging Face's VIT transformer to do that. It is a visual inference transformer, as you may have sort of gleaned. And what that's going to do is do a couple of things. One, it's going to read through our very, very large data set to know that it's looking at images of animals. The second thing it's going to do is it's going to insert about 10 raccoon images into that data set so that we have some raccoons to detect. And the third thing it's going to do is it's going to look at our data set of about 200 raccoons to train itself on like what we're looking for. So that's what's happening through all of here. And like I said, this takes a really long time. And I was trying to train this model again for no apparent reason other than I wanted it to be fresh for you all, but Hyperface does not want to talk to me tonight. So the thing we're actually most interested in terms of our like learning a bit of Spark is how Spark processes data. The nice thing about Spark and why it's so used for so many kind of like ETL pipelines is it processes data in parallel really, really easily. And it uses, I believe we're using pandas for this. Pandas is a batch processing, yes we are. Pandas is a batch processing pipeline. It allows you to do things in parallel, which when we're working with large data sets means that things go faster. So the next thing we're going to do is use Spark to kind of process through the inference and to do that in parallel for us. Which is really, really nice, and one of the great things that Spark can do for us. And then the final thing we're going to do is we're actually going to run the detection and say, please find me some raccoons. And when you find some raccoons, please publish them into a Kafka topic so that we have a run of our raccoons. So let's wish me luck. What's going on here? So, this is our Kafka topic. You don't need to worry about her. She's just kind of doing her job. The thing we are going to worry about is going to be on this other terminal that is very poorly colored. So, we're going to run python main.py. We're going to skip training because we've already trained the model, and that takes like forever. And we're actually only going to use a sample of 500 images because I don't want this to run forever. And hopefully, if I hit enter, everything will go correctly. But for now, we'll let that go on in the background. Where's my mouse? So, a few things to note about Spark, because again, we're here to learn Spark. Spark uses the concept of data frames to organize how things come into Spark and how things leave Spark. So typically when you load a bunch of data into Spark, it wants you to assemble them into a thing called a data frame. A data frame is basically like a temporary table, so if you're familiar with Flink, Flink does a very similar concept. It's also very similar to, this is only relevant to Snowflake customers, like materialized views. With very few exceptions, you're going to use the concept of a data frame a lot if you ever do get into Spark. What else do I have slides on here? We talked about Apache Parquet. Columnar file store, it allows you to store data and access it very, very quickly if you're dealing with really, really big data sets. So if you're involved in like Apache Iceberg conversations in your life at all, like apologies, but also you're probably very familiar with Parquet for similar reasons. What else? Pandas. So I mentioned that we were using Pandas to do kind of parallel processing. Pandas is a Python data analysis library. It has really, really strong support. With Spark, they're very often paired. I would sort of say the biggest downfall of this is that Spark is in the JVM, Pandas is Python-based, and so if you're doing stuff, you're moving things in and out of the JVM, that just like takes a bunch of time. We're not using MLib for hash tag reasons, but I think we already discussed this, so I'm going to go over this really quickly. This was for a meetup for Confluent. I didn't update the slide. You already know what Kafka is. But let's look at our little pipeline before we move on. Ooh, come back to me. So, our pipeline is run. And it has detected 10 raccoons, which is lovely. But I'll tell you right away, they're not necessarily the most trustworthy results. So for example, you'll notice that we've detected a Pomeranian, a cat, a chicken, a bunch of raccoons, which we expected, a Maltese dog, a toy poodle, and then a bunch more raccoons. But this is basically what the output looks like. And we were able to do this much, much faster than we would have if we weren't using Spark, because again, Spark is really, really good at helping us move through data really quickly. And when you're working with machine learning or AI, you're typically moving through a lot of data really, really quickly, particularly if you're in the model training phase. Okay. Wrapping it up. An inconvenient raccoon truth. I used an L1 for this code because, as I mentioned, I started my life as a technical writer. And as some of us were discussing over the break, a lot of using L1s or using generative AI is really being able to break down a problem such that a computer can understand it. And fundamentally, these tools are still computers, and they still think about problems in computer-shaped ways. I was able to get to the output that I wanted, that was valid and decent code, because I had 10 years under the hood of being a technical writer, describing code, and having to think about code in a linear fashion that is explainable to other people. But I do think it's a really, really important thing to note, especially as we kind of move forward into this new kind of vibe coding life. What does it mean for technologies like Spark, which are really a lot of people's bread and butter from an employment perspective? And what does it mean to be a coder in all of that? This is my working group, but I think this is exciting to this particular crowd. I did ask the LLM if there was anything we could have done differently, and I think this is another important conversation, specifically to have about Apache Spark in 2026. As I've mentioned a few times throughout the duration of this talk, it is a pretty heavy install. You're typically deploying it as a cluster. It is JVM based. It's relatively just resource intensive. It's not necessarily cloud native, so you can deploy it to Kubernetes. You can play alongside your cloud native technology, but that's not its mental model of the world. And I think the important thing to think about Spark is for everything that Spark does, and all of those raccoons in a trench code, there's probably an alternative that is more lightweight and more modular that you could use today if you wanted to. And I think that's just an important thing to know. You're going to encounter Spark in your life and your careers because it is in deployment in so many different places. It's not necessarily the choice you would make doing something from scratch in 2026, in my opinion. We could have done some more stuff. That's all I got for you. But yeah, thank you very much.
Questions for Celeste? Are you muted?
I am. Yeah. Sorry, I didn't have a QR code. Yeah. Thank you all for your time.
Yeah. So personalization, not a new concept. We've all experienced some sort of personalization. It's been around for a while, since the time people were writing their names on coffee cups to making special meals for us or doing something special at a hotel. And now, more recently, we think about it as personalization in apps and other products like Spotify or Netflix. But Spotify's actually been around 18 years, guys. Did you know that? So for me, I work in this space. I have a lot of thoughts about personalization, and I would love to have a quick chat where I'll share some of my experiences that have evolved my understanding, and yeah, and hopefully that'll be helpful. And I've chosen to go really broad in the interest of time, and also if you need any additional technical details or anything, come find me later. But yeah, I thought this would be useful. I am a product person, so that's the approach I'm coming at it from. Quickly, the research will tell you that personalization drives 15% additional revenue on average, 70% of customers expect it, so it's essentially table stakes at this point. But most people think about it as more personalization, the more instant, better. So
top right quadrant is generally where people think we need to get to. But the truth is that making personalization work in the real world is a far more nebulous thing, and they're really murky waters. So that's what I'll be talking about today. A bit about me. I have been around. I speak 6 languages, lived in 6 countries. I spent a number of years working across product, venture, go-to-market in really diverse industries, from marketplaces to now retail. I've also done lots of other things, like work for the government of Ecuador on trade between India and Ecuador, and do international expansion for a Series A company, and work with a nonprofit with underprivileged kids in India doing digital storytelling. So all of these experiences, I think, are part of why I'm so curious about human behavior, and specifically what makes decision-making really difficult, and also how do we design that perfect customer experience that's truly meaningful and valuable. All right, so I'm going to go through 3 experiences, and then we'll chat later. So in 2020, I decided to found an edtech company that was designed to help students figure out where to go to university. The problem was, at the time, guidance was really expensive or biased or generic, and this was a really life-changing decision. For those of you who have applied to university in the US, it's expensive. It's 4 years. Kids often leave full of regret. So we wanted to do something about that, and the assumption we had was that sort of taking this really specialized guidance advice and codifying that knowledge that's usually held by counselors and scaling it would be able to democratize access to sort of better decision-making in this space. And we started out by thinking we wanted to make these creepy good lists that really knew you really well, and that the interface would be really student-friendly, and we started out by making manual lists for kids, and those took us 5 days. And so the thing is, at the time, we were a startup that had $0, and we really needed to get traction quickly to be able to get investment, which we eventually did. But the thing was, we needed to scale, and we needed to do it quickly. And so we started out by trying to get to that top right quadrant, because it was 2020, so for us. And we thought we would use machine learning and get data scientists to do all kinds of things with data sets. And ultimately, most of the data we had didn't have any sort of hidden patterns in it. And ultimately, what we used was just segmentation and heuristics. So coming up with really good segments of universities that we have crafted, as well as cohorts of students that, based on the information they would submit through our portal, ended up getting us a lot of good impact. So we had hundreds of lists made within sort of a few weeks, and then we got to pretty good quality, so 70% favorite rate, which was the proxy that we used. The point is that segmentation works. So segmentation is a really good solution for a lot of cases like this, where you're early, where you don't have money, and it gets you quite far. Today, of course, just a quick note, in this industry, first of all, it would take maybe days for us to build what took us months to build, using the tools that we have now, but also students can really easily go onto ChatGPT or some other tool and just put everything they have about themselves on there, and within maybe minutes get a really good a good set of schools for them. And those tools also do look at sentiment analysis, all of these special things that we were doing. They're already kind of part of the sort of table stakes now. So just a note on the previous example. So in the previous example, what was sort of missing was data about how millions of students were applying to universities and then getting rejected or accepted, and that's the kind of data that you need to be able to build good ML solutions. But I wanted to touch on something that those who are in DS will probably know very well, which is this theory of the bitter lesson. Essentially, heuristics work really well in these constrained environments, but over time, as you increase the complexity, that tends to struggle, and the learning systems actually do much better in these situations where there is scale. And so that's kind of the general principle that a lot of certainly my data scientists will throw at me when we're coming up with problems. But the truth is that heuristics can get you quite far, and it's often a really good solution, especially if you're sort of constrained in any way. I'm going to jump now to sort of the other end of the spectrum. So this is a company I work for, Tesco. Some of you may have heard of them. We have 23 million customers. We're doing all right, 29% market share. But you know, it's still a pretty competitive space, and it's always important for us to continue being relevant to the customer. So when we think of personalization, which is the domain I'm in New York, we think about making it relevant, helping customers do something faster, get a better option, make it cheaper for them, etc. And so, a quick note on the methods that we use. I can't say too much because I'd have to get CTO approval, but we basically do things that you'd expect elsewhere. So we build affinities based on your basket information, so your purchase history, and we do a lot of work on propensity modeling. So we look at what you might buy, what you might do next, all that kind of thing. And so these are very similar to technologies used by teams at Spotify, for example. And these do a really good job of improving relevance and improving performance. And in a situation like Tesco, where you have millions of signals, it is worth making this investment. Obviously, on the other end of the spectrum, the previous example that I showed, that would not make sense, but here, even a 1% improvement on something can drive like millions of pounds of benefit or cost savings, etc. And so, I guess it's kind of obvious that scale does change your personalization strategy, which is the point I was trying to make through this presentation. But the other thing is, as I've been in this space for some time, with these products and these experiences where you've got like lots of different personalization touch points, what often happens is you don't really build a coherent story. So you have various teams who are kind of shipping stuff, and you're measuring impact across different touch points, but there isn't necessarily a clear view of what value you're driving over the journey or over the experience for the customer, and that's going to become more and more important as we move into this agentic commerce world, where you're no longer actually, a customer may not be interacting with you through a UX, but rather like a software or agent is reaching out to you. So it's very important for you to codify what exactly that customer needs to experience and why, and make sure that it translates into this future that we're going into. The other thing about this, and I'll touch on this really quickly, is most of what we do, so everything that we do at Tesco and a lot of other organizations do in this space is using your past behavior. So we pretty much just know who you were. We don't really know who you are in this moment. That's changing a little bit. And we would love to be able to figure out who you want to be and help you get there. So now there's a lot of discussion around how we can be more context aware. And the goal there, again, is like kind of on that graph that I showed initially, to be even more relevant, to know what you're doing currently and then be able to adapt to that. And I just want to say that companies that are doing adaptive modeling and adaptive systems, those are very resource-intensive solutions, so only like a handful of companies can do it. But the idea is basically you can add additional signal that you can gather through things like event streaming, which we are starting to do more of at Tesco, but also through LLMs. So we currently have something in beta that's coming out to customers as well, but essentially capturing more information about what the customer actually is feeling and wanting, and being able to do that. So some of you may have heard of the next best actioning approach, which delivers that tailored intervention at the moment that you're doing something. But again, just kind of going back to the theme of trade-offs when you're personalizing, that might not be necessary for a company, even like Tesco, where you're shopping basically like once a week. But maybe if you're Spotify or you're another company where customers are constantly giving you signal multiple times a day, whether there's something specific that you want them to do, your subscription model, that might be more relevant for you. The last example, again, these are raccoons in a jacket, but this is something I really enjoyed working on, the online language learning space. So again, language learning is a space that has benefited greatly from all the advancements in NLP and AI technologies. So in this particular case, I was working with a company that helped people learn English. And anyone who here speaks more than 3 languages? Okay, great. Who's learned as an adult? Okay. Yeah, so learning languages is hard. It's basically what you need is repeated practice and exposure, ideally immersion. instant corrections, either in the form of a teacher or something else, unique corrections, and you need to feel comfortable, and you need to feel like you're confident and not being shamed. And so it's a very specific thing that's sometimes hard to recreate. But there's also lots of companies that do language learning, and with the advancements I was mentioning, like this space has basically collapsed, where it's very easy to spin up one of these like AI language learning companies. So I was working with this company as pre-seed, had a bit of traction over a year with some returning users, and was essentially in this trying to monetize phase of their journey. And I'll go into exactly what they're doing. So I thought it was a really interesting approach to personalization. So I'll speak a little bit about exactly how the technology works. In this case, they were using LLMs. So the student would come on to the lesson, it would just be sort of them and somebody else, and they'd be speaking. And just to be clear, it wasn't really a lesson, it was a student with another student in a one-to-one. We would sort of use the recording to generate a transcript, and then an LLM would sort of query it and give them corrections within minutes. So not instant, but within minutes. And those corrections would be surfaced in a really sort of friendly, somewhat conversational UI. And so, actually what this experience taught me is that LLMs had reduced the cost of delivering the feeling of personalization, which is really what personalization often is. And interestingly, people feel like some of these like emotionally resonant UX changes that are made feel way more personalized than some sort of hyper-optimized adaptive system in the background that people can't tell is sort of personalized. And so it was a way for it to be valuable, but also to feel really personalized. And this particular business made some really interesting trade-offs where they uncovered that what really mattered to the students was that human interaction, so being in that class, in that session, and that safety of sort of being with other human beings. But then also what they really valued was being able to speak to somebody at their level. And so instead of spending a ton of money on using sort of the best model to query the transcripts or to get the best kind of transcript generation even, they sort of spent their money on building a tool that would help them match students better, sort of create scores and do that. And so actually they were able to monetize, and I guess what they were able to do really well was understand which part of where personalization could actually drive impact in the journey and drive that stickiness, which is really what they needed to get to their next goal. And you can do tons of other things with LLMs, like you can use a transcript in that last box there. It's supposed to be flashcards, so you can do all kinds of things and personalize lessons. I think what's interesting with AI is it was really difficult for them to monetize because you've got ChatGPT where you can just speak to it, it can give you a really personalized lesson plan and help you with specific vocabulary, for example. So figuring out really the human element of this experience, like what actually people will pay for, was probably the most important thing for them at the time, rather than sort of investing in this technology. So lastly, I'll summarize by saying, just when you do personalization, it's important to think about what you're actually optimizing for. It isn't just maximum sophistication all the time. Collecting signals is fine, and that's exciting that we can do more of that with other AI advancements, but the focus should really be on maximizing the user value per unit of complexity, because these things can get really complex and expensive and just unwieldy. So yeah, that's my talk. I can go into this in a little bit more detail if anyone has any questions. And feel free to connect. Any questions? Thoughts? Yeah.
I found it quite interesting. Actually, I'm working on all the personalization stuff at the moment, but from a non-tech point of view. Obviously, one of the big challenges you mentioned was obviously learning from people's past, not so much present, and be more difficult in the future. What sort of emerging technology have you come across that has kind of helped you tackle that problem?
Yeah, so I can't say much about what we're doing at Tesco, which is convenient because actually we're not doing too much of this. It's a large order that moves slowly, but there are tools that will, for example, you can take all of the customer's history, you can condense it using, I don't know which transformer architecture, into like one embedding, so it's your whole journey, it's not all these various transactions, into one journey, into sort of one embedding, and it compares you against other people who have had certain journeys, and using that you can actually develop interventions. So it just depends on the company. Like I think Tesco, like we sort of assume that everyone shops once a week or periodically. It's not like Spotify when you're coming on and you're listening to songs all through the day where you can really have these interventions, you can collect data points. So yeah, that transformer architecture is one. The whole next best action in the industry is pretty big. So like we recently partnered with Adobe, which I'm sure some of you may have heard in the news, but like a lot of these companies are actually trying to build those systems themselves, but they're really complex. I don't have much to say other than the bitter lesson bit is usually what they're talking about here is reinforcement learning, which is not what we were doing in Ireland really at all at Tesco. We mostly just use supervised learning. But reinforcement learning is like you just give it an environment and it comes up with its own policies and how things should work. Now, reinforcement learning combined with next best actioning, those systems are super expensive and like really, that's like a whole thing in itself, which I don't think we're really there. But Spotify for sure and some of these other companies are investing in this technology. So I don't think really answered your question other than we don't really do too much of it yet, but this is more me thinking about it because I work in the space. Anyone else? No? Okay, all right. Thanks, guys. Well, anything else?
I think our curfew here is, let's say, 10 to 9.
10 to 9, yeah.
So, yeah, there's a lot of pizza and my fridge is very small, so please try and eat as much as you can. Don't make yourself sick.
Thanks, everybody.
Yeah.